Okay, so now I will illustrate the example in which we will apply the sum rule for the solution of non-homogeneous differential equation. The sum rule is applied when you have the we have the Rx function, which is the combination of two or more different types of functions. So let's see this equation: y double prime plus y prime 2y prime is plus 0.75 y is equal to 2 cosine of x minus 0.25 sine of x and plus 0.09 of x. This is the solution. So in this case, this function on this right hand side is the combination of two types of functions. So this is the trigonometric function, and this is the polynomial function. So first of all, we will find the root of the homogeneous quadratic equation, so for which the characteristic equation is m square plus 2m plus 0.75 is equal to 0. If I just multiply this characteristic equation by 4, it will be 4m square plus 8m plus 3 is equal to 0. So I have removed this point sign from here, so I can write this equation 4m plus 2m plus 3. I take 4m as common. So I can write it as 6m, because 6m plus 2m is 8m. So I can take 2m as common, so 2m plus 3 and then 2m plus 3. So this will factorize into 2m plus 1 into 2m plus 3. So the roots of the characteristic equation are m is equal to minus 1 by 2 and m is equal to minus 3 by 2. So the solution of this homogeneous part of the equation will be, if I take this first term, c1 e power minus 3 by 2x plus c2 e power minus 1 by 2x or x by 2. This is the homogeneous solution. The particular solution will consist of two parts, yp1 and yp2. Okay, so the sum of these two will be the sum of the total particular solution. This plus this. So for yp1, this is a trigonometric function, so we will assume the solution is a cosine of x plus b sine of x. So to find the undetermined coefficients a and b, we will need to differentiate. Minus a sine of x plus b cosine of x. Differentiate again. Equal to minus a cosine of x plus b minus b sine of x. Okay, so now we need to substitute these primes into the original equation. The original equation was y double prime plus 2 y prime plus 0.75 y So this will be then equal to y double prime value was minus a cosine x plus b minus b sine x, and then y prime value is here, we have to multiply by 2, so it will be minus 2a sine x plus 2b cosine x. Okay, and then the value of y p multiplied by 0.75. So it will be 0.75 a cosine x plus 0.75 b sine x. So a long expression. This will be equal to the 2 cosine x minus 0.5 sine x. 2 cosine x minus 0.75 sine x. 0.25 sine x. So it is 0.25 sine x. Okay, so now we have to compare the coefficients of sine x and cosine x. So here we will take the cosine x terms first. Cosine x, and cosine x. So what are these terms? Minus a plus 2b plus 0.75, and the coefficient of cosine x over here is 2, so that is equal to 2. Now we will collect the terms of sine x, and sine x. So it will be minus b minus 2a and plus 0.75 b. So it was a here. So equal to minus 0.25. So this equation simplifies into minus 0.25 a plus 2b is equal to 2, and this equation simplifies into minus 2a minus 0.25 b is equal to minus 0.25. So if we solve this equation, so for example, if I multiply this equation by 8, so then I will get minus 2a plus 16b is equal to 16, and then I subtract these equations, so I get minus 16.25 b is equal to minus 16.25. So here I will get b is equal to 1. If I get b is equal to 1, so I input b is equal to 1 maybe in this equation. So minus 2a minus 0.25 into 1 is equal to minus 0.25. So minus 0.25 minus 0.25 cancel. So a will be equal to 0. So now we got a is equal to 0, b is equal to 1. So this means that the first particular solution will be equal to 0 cosine x plus 1 sine x. So it is sine x only. Okay, the second particular solution is a polynomial here. So we will assume it to be equal to this was equal to 0.09x. Okay, So we will assume to be, because it was a polynomial, so second particular solution yp2 we will assume as equal to, it was in terms of x, okay, so we will assume it is equal to cx plus d. So yp prime will be equal to c and y double prime p2 will be equal to 0. The equation was y double prime plus 2y prime plus 0.75. So y prime was 0, 2y prime is 2c, and 0.75 will be 0.75 cx plus 0.75 d equal to 0.09 x. Yeah, 0.09 x. So now from here we know that yeah, so it was 0.75 x cx. So now from here we know that 0.75 c, which is the coefficient of x, should be equal to the coefficient of x on the right hand side, 0.09. So from here we can find c is equal to 0.12. So c is equal to 0.12. So we can find now d. So from here we see that 2c and 0 plus 0.575 d is equal to, there is nothing over here, so it is 0. So 2 times 0.12 times 0 plus 0.75 d is equal to 0. So from here we can find d is equal to minus 0.32. Okay, so now yp2 is equal to then 0.12x minus 0.32. So the overall solution is c1 e power, that is the overall general solution, e power minus 3 by 2 x. Let me write it better. So it is minus 3 by 2 x plus c2 e power minus x by 2 and plus sine x plus 0.12 x minus 0.32. So this is the general equation. So now we have two initial values. These two initial values are y0 is equal to 2.78 and y prime of 0 is equal to minus 0.43. So if you will apply these initial values and do the necessary calculations, so the final answer, including all the initial value problems, will be, in this case, then c1 will drop out, c1 will be 0, and then c2 you will get is equal to 3.1. So your final answer will be y is equal to 3.1 e power minus x by 2 plus sine x and plus 0.12 x minus 0.32. So due to the time limitation for this video clip, I am not showing the calculations for this initial value problem, but you can do it very easily. So the main lesson we learned in this example was that we have applied the sum rule. That means if the Rx function is the sum of two functions, and we can make the sum of that